Welcome to my unit testing design course. This was a presentation that I had given to my teams back when I was newly promoted to the lead developer. And they'd been struggling a lot with trying to get unit testing incorporated in because there was a mandate from on high that thou shalt unit test, and in and of itself that was perfectly fine. But the team was having a lot of difficulties in a lot of different places. And in certain cases, the problem really amounted to the design of the code was actually acting as a barrier for being able to successfully accomplish their tasks. So I had created the talk, and since unfortunately that is sitting on a server at my company and it has proprietary information on it, I've decided to redo this in a publicly accessible way. So I hope you enjoy it. Every good testing demo needs a dead simple problem to work on. Typically it ends up being something like a calculator. What we're going to do is something I'd say is a tad more interesting. And what we're going to do is we're going to look at one aspect of some banking software. Specifically, a bank needs to be able to convert money between currencies. So for instance, you can imagine that you can deposit a US check into a Canadian account, or perhaps you have an Australian credit card and you're purchasing something from Amazon UK. So to be clear, what we aren't going to be doing is modeling anything related to the accounts or banks per se. What we really want to look at is this aspect of currency conversions. So it's surprising how just this one simple task is going to be able to demonstrate all the topics that I'm going to need to in this series. So I want you to imagine that we have a well-intentioned intermediate software developer. Okay. This person has gathered some requirements and is putting together their C# class. So the meat of the object is going to be this convert currency function. So you can imagine that what we have here, we've got something that's going to take a source currency, and there's going to be a target currency and a particular amount in the source currency. And the job of the function is going to be to produce the correct amount in the target currency. It's also been decided that there's going to be no fractional pennies that are going to be returned back, so you're always going to have to round to the appropriate value. And I realize that penny is not applicable to all currencies, but for the most part, this should make sense. At some point in time, regardless of the currency, there's a point where the money can no longer be divided any further, for at least for the purposes of tracking, as you would find in people's bank accounts. Now, a good bank needs to be able to make money for its investors, so the converter object is also going to have to be able to deal with something like a commission rate. So what we're going to do is define this simply as a percentage of the amount that's going to be taken off whenever a conversion takes place. Now you can imagine that this conversion is going to potentially be passed into the convert currency function. We're going to make this a little bit simpler and just keep it as a property on the class itself. So let's take a quick tour of the implementation. We can see that we have an enum defined for each of the currencies that are going to be used. In the class itself, we have two member variables. The first is the commission percentage. That relates to what we talked about in the previous slide. There's also going to be a dictionary that's going to keep track of all the USD conversions. So what we're going to do is keep track of how much $1 US is worth in all the other currencies. And at that point in time, we can convert from any one currency to another by using this conversion table and using the US dollar as the intermediate. We could have stored this as a full two-dimensional table, but given the fact that we have the data here, it would be unnecessary to have to keep track of all the pairs of currency. Let's take a look at the currency converter constructor. So we said that's going to take the commission, and that's going to be kept track of for the entire lifetime of this object. And then we also have this load current USD conversion rates function. So this is a private helper function whose sole responsibility is to be able to load the conversion table. So as you can see here, I've defined this as a static dictionary. For now, it's containing the values that I scraped off of the web a couple of days ago. You can imagine it being more sophisticated, actually reading the data off the network live and dealing with the fact that currency rates will change as time goes on. But to keep things simple for this demonstration, for this unit testing, this is going to suffice. So now we can get a look at the actual function that we're going to be focusing our attention on. So the code here is only about 12 lines of code, 10 if you don't count the white space. The code's pretty straightforward. First, we validate that the currency conversion is actually necessary, because if it's in the same amount, then you're just going to simply return back. Then we take a look at what the currency conversion rates are for both the source and the target so that we can ping pong from USD and back. And then if you look at the last 3 lines, this is just the basic of the math. We're going to make sure the bank takes its cut, and then we're going to convert from source to US dollars, and then from US dollars back into the target currency. So you can trust that my math is correct in those 3 lines. Oh wait, no we can't, which is the point of the unit testing. And this is exactly what we're going to do, is we're going to structure our test to be able to see if we can find out if there's any bugs in the code that we end up having here. Now, as a quick aside, one thing that I'm going to ignore is the fact that if the bank is going to do a conversion and we see that it has to take its cut, well, the money actually needs to go somewhere. For now, the focus of this function is just on the value computation. And really, it kind of makes sense. The responsibility of doing the actual putting the money where it belongs would more belong in, say, the account class. So for the purpose of this function, all we are worried about is the actual values that are going to be changing. So now let's take a look at unit testing without a framework. Imagine what we would have to do if we were to do this without any help. And everyone's done this. Usually this devolves into rolling your own test harness that you run from the console. And we've written countless console test apps in our lifetimes that are more or less all take the same look and feel. So let's go back to my code and let's look at the one that I quickly whipped up. And I did not spend any reasonable amount of time on this. It was done very quick and very dirty. So you can see that, we've got a main that's going to iterate through a whole bunch of tests. And what are each of the tests? Well, they're all static functions, and that's going to encapsulate one particular test. So the first test is going to test that if you go from US dollars to US dollars, you get the same value back. Then the second test is going to go from Canadian dollars to Canadian dollars and make sure that you get the same rate back, or the same value back. And then we're going to do it with, what if we have the bank currency, the bank conversion rates being defined? Do we have to do anything there? And so on and so forth. And then, as I said up above, we're just going to iterate through all the individual tests and check to make sure that none of them return false, presumably indicating that the test failed. And then as you run through the tests, you're going to see that one of the, if nothing gets printed out, everything must have been good. But if one of the tests produce an error message, then you know that that test ended up failing. So for instance, if I realize the numbers are out of order, if test 5 had failed, then you're going to see that printed out to the console. And at the heart of it, this is fine. You know, this is going to work. It's not the end of the world how we're doing this, but the thing is, there are much better ways, and there's also still a lot of warts in what I've written up there. And again, that's based on the fact that I spent all of about 5 minutes doing that. So for instance, back in that case, if that first test number 5 had thrown or asserted, instantly we run into a problem because none of the other 4 tests would have ended up running. Or if this was a part of a large test suite that had 1,000 other test cases that were in there, none of the other ones are going to end up running. And unfortunately, that means that you're going to have to wait for another build cycle before you can get the result of all those other tests. It's also really annoying if you look at the output for my test harness. It's going to say test 5 failed. Well, what did test 5 do? Well, sure, I suppose I could have put more work by actually making, more meaningful strings that are there. But again, this is going to come down to me having to put more stuff in there. And then I still don't know why the case particularly failed. At that point, I'm probably going to have to try to divine some way of being able to try and give feedback to why the test ended up failing. So this really gets to the heart of the issue, and that's that this doesn't scale very well. So testing all the individual currencies one by one, well, that's going to be a little annoying. I'm going to have to possibly make, 10, 11, 12 separate tests that are all going to look basically the same. I suppose I could put them all together into one Uber test, but now we're still back to the problem where if one of the subparts of that Uber test fails, then I don't get information for all the other currencies. And then we have the bigger issue of how are we going to deal with this at the application level. So I have this nice, wonderful test app that tests my currency conversion class. But what about the other 10,000 classes that are going to be part of this much, much, much larger banking software? Are we going to have to run 10,000 individual test harnesses? Are we going to have to come up with some system where Jane's going to come up with her test harness, I'm going to have my test harness, Bob's going to have his test harness, and we're going to have to some way find a way for them all to mesh together and unify them all? And then more importantly, this is a problem that gets a little unwieldy. And then at the end, we have to make sure that we come up with a way that we can decide did all of our tests pass or not, because if they don't, then we need to fail the builds. So, and let's be honest, we're supposed to be right now in the business of writing banking software, and it suddenly feels like we're in the business of writing crummy test harness code. This is a solved problem. So why don't we use one of these pre-existing solutions instead of trying to reinvent it ourselves? So let's go ahead and show how easy it would be to be able to make an xUnit test for the class. So we can do this right from inside the IDE. So the first thing we're going to do is we're going to go in and we're going to add a new project. And it's going to be, already here we see xUnit test project.NET Core. So since my original code was .NET Core, I can be able to use that. Now, if it turns out that you're using, say, .NET Framework, all is not lost. All it means is that you're going to have to make your own NuGet package references, and you're not going to get anything that this template automatically gives for free. It's not much, so you're not very far behind when you do that. So now what we're going to do is we're going to give our project a nice meaningful name that we have here. So here we go. Let's call this the test converter project. And we create it. So let's give this a meaningful name rather than unit test 1. There we go. And last, we're going to add a dependency on our bank class. All right. So already we've gotten one free test case that's already been produced for us. If we take a look at the Test Explorer, we can see that this already appears. Now you're going to notice that the hierarchy of the test is actually going to follow a pretty logical structure. We have our test converter project, so there's the top level of the hierarchy. If you have more than one project that has unit tests, they'll all be at the top level. Inside of that, we see that we have the unit test currency converter class. So we have our unit test currency converter class at this level. And then inside of it, we can see the actual individual test that we have inside. So there's our test 1, and here's our test 1 that we end up having here. So now we can go ahead and we can actually build and run this. So I'm just going to dock this. So we click the play button, and what this is going to do is run all the tests that it knows about. And it doesn't know about much, it just knows about the one. And we can see that the test succeeded. And of course, that makes perfect sense. There's no reason for it to fail because the test case literally did nothing. You can imagine us putting in something that would make the test fail. So we're going to assert that 1 is equal to 2, and that is definitely not going to be true. So if we go and rerun the test now with that in there, we can see that the test is going to fail, which is going to in turn fail the class, which is going to in turn fail the project. And if we click on the individual test, it's going to tell us, hey, someone asserted that we were expecting a value of true, and what we got back was false. So we can roll that back. So now we have something to go on. We see that it captures the variables that we need. So this is all very usable. So this is what I was saying before, where this is a solved problem. It took all of about 15 seconds, and already we have something that is infinitely better than what I had tried to cobble together with the console test application. What's nice about the Test Explorer is it also gives you the ability to run an individual test, so I can right-click and just run the one. I can actually debug into the test if I want to see why it might be failing. I can run all of the tests for a class, or I can just, multi-select a subset of the ones that I want. So again, as I said, it is infinitely more usable than anything we could have possibly come up with from before. So now that we have a framework in place, now let's actually take a look at actually starting to write some of the unit tests. So xUnit tests are broken down into two categories, facts and theories. We're going to start with the simpler of the two, which is going to be the fact. Now, all a fact is a test that confirms a single invariant truth about the software. So on the side here, you can see that I have the framework for what one of these facts would look like. So to start off with, we have what should hopefully be a pretty meaningful name related to the tests. So what I've done is I've given one possible recommendation that I see floating around, where the name of the test has 3 parts to it, separated by underscores. So the first part is to identify what functionality or function specifically that you're trying to test. Then you have the action portion, which is going to state what it is you're trying to test and what possible state conditions revolve that test. And then the last part is what you expected to be the outcome for the corresponding test. And the reason you do this is that if you end up having a test fail, rather than getting some gobbledygook like, oh, test 5 failed, what you're going to see is something that hopefully conveys very quickly to the person who's reading the test report what exactly went wrong. We see that we have to have the fact attribute that's put on there. And it's because we put the fact attribute on that it allows the Test Explorer to be able to scrape the files looking for all the unit tests that they want to be able to put inside of the Test Explorer. If we take a closer look at the signature, we can see that for a fact, there's going to be no parameters to the function. And that makes sense. If it's a single invariant truth, we're going to be able to capture that one statement of truth entirely inside of the body of the function. As well, we can see that it usually is going to return void. Now, don't worry if you do something where you say need to await something. You can always change this to be an async task and it will still behave correctly. And as well, we also generally make the functions public. As for the body, we organize it into the 3 blocks. And we can see over on the right-hand side, I've given the nice names for them. And you will notice that they all start with A. And this is hopefully to make it slightly easier to remember what they are. So you have the arrange portion, which is where you end up assembling or setting up the tests. Then you have the act phase, where you're going to actually perform the particular actions that are needed to create the desired test inputs. And then finally, you're going to assert that you're going to get either the correct results back or you've left the objects in a particular state. So you're going to validate that you get the correct behavior. So now, let's go ahead and take a closer look at what an xUnit fact might look like. So if we take the existing code that we have there, let's go ahead and give this a much more meaningful name. So we can see that we have convert currency, USD to USD, return same amount. So as we said, the first part was going to be where the function that was being tested. So we're testing the convert currency function. Then we have the middle part that says, what are we trying to test? Well, we're trying to test that converting from US dollars to US dollars is going to be what we're going to act on. And what we're trying to check is to make sure that we actually get the same result back. In terms of the body, we can fill in initially the 3 phases, so the arrange, act, assert, and then one by one we can be able to put in each of the individual parts that we care about. So for instance, for the arrange portion, well, we're going to need to create the actual object that we have there. So here's where we're going to create the currency converter. We have to define the bank rate for it. So for this test, let's just use 0% as what the commission rate is going to be for the bank. And then the last part is we need to decide how much money it is that we're going to be using. So I've just defined a constant here that's going to have that. So now we can do the act phase where we're actually going to invoke the corresponding function. So we're going to call convert currency on our converter. And as I said, we're going to go from US dollars to US dollars, passing in the value of $999. So that's going to give us a result back here. And then in the assert phase, we can do the test to make sure that we got the same amount back. So that's going to be pretty easy. What we're going to do is we're going to assert that what we got afterwards matches what we got before. So the expected value goes first and the value that you're testing against goes second. So now that we have that there, you'll notice in the background the Test Explorer has been chugging away. It's figured out the correct name for our unit test that we have there. And now what we're going to do is we're going to be able to run all the tests that we have. So let's go ahead and we're going to run that one test, and we're going to see that it succeeded. So we see the 3 green lights. So one of the things I want to point out is to not go assert crazy. Oftentimes people recommend that you put a single assert in, or occasionally you put in maybe 2 or 3, but those being the exceptional cases. And the reason why is that if you fail in assert, that's going to stop the test case right there, and it's not going to be able to run to be able to give you any more meaningful information. Since we have the robots here running behind the scenes, running the test harnesses here, we should strive to make the tests as fine-grained as possible, and we're going to let that test runner do all the work of being able to rerun the same things over and over again. Again, if you look at the times of the test cases, it's already for this one 5 milliseconds. Well, that 5 milliseconds is actually 99% of that work is literally just setting up the test that's there. The individual test cases themselves, after everything gets bootstrapped and running, is probably going to be sub-millisecond anyway. So you could have thousands of these tests in there, and you're not going to appreciably add much time to any of your builds. So now let's take a look at an xUnit theory. So this is another category that we have. And unlike the fact, which was a single truth, a theory is going to be a test that you're going to want to test against multiple inputs. Now, generally theories are used when you want to repeat the same test a bunch of times using a different set of data each time through. So the test functions will still return void, but now we're going to have a parameter list that's going to be customized for that test's needs. So let's go ahead and write a theory for our currency converter. So if we go back here, let's go ahead now and add something in here for, effectively it's going to look like much the same test that we had before, but let's make it so that we can run on all of the non-USD currency rates. So the code is virtually the same as what we had before, but the only difference is going to be instead of these hard-coded constants here, let's actually make it a parameter, currency, that we are going to end up passing in. So now that we have that in place, we're going to, just as we did for a fact, we're going to designate it as a theory. So we annotate it with the attribute. And now we end up having the ability to be able to now come up with a way to be able to, now we need to put in some test data for it. So you can see if I hover over this, it says, theory methods must have test data. Well, yes, it does. So, right, we need to have values that are going to be in there. And the simplest way that you can do it is with an extra attribute that we can put on our function, which is inline data. And what the inline data is going to be is we're just going to hard code for a particular test what we'd like that value to be. So currency.euro is going to be what we're going to pass in. So what's going to happen is the test runner for theories is going to be able to call the function now with these parameters being passed into what you end up having here. So you can imagine, well, what if I had two parameters that were there? So imagine I had an extra parameter, int x or something to that effect. Well, now we need to specify two values to be passed in. And you're going to notice that the inline data says, whoa, hey, you're supposed to have the correct number of parameter values there. Again, it can go through and detect that you have the wrong number. So that tells us that we need to put something in here to match the corresponding numbers. So if we had two parameters, that 12 could then be passed in. So that's all it's going to do is just take these two values and use it to pass into the corresponding, for the corresponding function. Well, let's get it back to what we had before where it was just doing euro for the currency. And now we can go ahead and we can run this particular test. So I'm just going to run it all because it goes very, very quickly. And as I said, most of these additional tests, they're all going to be running in less than a millisecond. So the test ended up succeeding. Now I'm going to make this stretch out a little bit wider here just to show you that the test case, and I apologize for how long this goes, is actually passing in there. It's saying, hey, this test case actually covered the euro currency. So, well, it doesn't seem like I've gained all that much from what I had before, right? I mean, I basically made something that was really, really straightforward in a fact, and I now made it a little more complicated. Well, I said the whole point of doing the theory was so that we could test with multiple pieces of data, and that's exactly what we're going to do. So you're not restricted to just specifying one piece of inline data. You can specify as many pieces of inline data as you need for your test. So now when we run through this particular test case, it's actually going to go through and it's going to rerun the test case each time with each of the individual currency values that we end up having here. So this time when I end up running it, we're now going to have about 10 tests, and you're going to notice we got an extra little branch here inside of our hierarchy that's going to show you all of the ones that we end up having there. I'm just going to hover over it so that you can end up seeing it, but you can see that at the end it says, oh, this one was for Australian dollars, and you can see that this one was for British pounds. And in this case, we can see that all of the individual tests ended up passing. So at this point, it should be obvious that I probably could have folded this original test case for the fact that we had up here. We should probably fold it in here. Again, the reason for the simple fact was to be able to demonstrate the test case. And yes, in reality, you would not treat the US dollar as any different from the ones that we end up having here. So one thing that's worth pointing out is if we take a look here under some of the settings, you can see that you can actually start running the tests in parallel. And for our purposes, if we do that, it shouldn't fundamentally change anything. And you might be thinking, well, whoa, hold on a second. What's going on here? Aren't you going to be, possibly running into thread safety issues or something like that with all these cases running simultaneously? Or are they going to be sharing some of the same, converters? Well, no. When the test harness runs, each one of those individual test cases is going to be run in a completely separate run that is 100% independent from all the other ones. So they all can be run in parallel, and it's not going to impact things at all. And again, to reiterate, if you can see all those other test cases that we end up having there, all of them were running in less than a millisecond. Again, that initial 5 milliseconds to start up was going to be probably the highest number you're going to see for any of the tests that we have. So now that we have this test case here, let's go ahead and write one more of them. So let's go and write one that's going to deal with what happens if the bank actually does have a commission, because we're going to want to make sure that in that case, when we're doing same currency to same currency tests, you want to make sure that the bank isn't going to be possibly taking any of the commission that they have there, because again, it's only supposed to be when the money actually involves a currency conversion. So as before, we can create our test case. Again, it's virtually the same, except now we have a different bank rate. Well, we'll use a different value here of $777 instead of $999. And now we've got this test. You're going to go, well, it's time for me to start putting some inline data in here. So let's go ahead, and it's going to be the same as what we had before. So let's copy and let's paste. And this is the point in time where you should feel a little bit bad about what we've done here. And this is a problem. What would happen if we ended up adding another currency later on? Then I'm going to have to hunt through all the test cases to find the right ones that have the right inline data that are there. And again, this is a case of we've got code duplication here, and as much as possible, we'd like to avoid having the code duplication. Fortunately, there is a nice mechanism where we're allowed to be able to say to the xUnit framework, hey, for this theory, I'd like to use the same data as what someone else is using. So let's go ahead and take a look at doing that. So instead of writing the inline data, what we can instead do is we can procedurally generate the test data. So I'm going to warn you that the function that you end up writing, it's a little bit of a mouthful, but what you do is you specify using this MEMBERDATA, hey, instead of using inline data, what I'd like you to use is I'd like to use this function that I've called all currencies and have it provide the data for us. So as I said, it's a bit of a mouthful, and what this function has to return is of a very specific type. So the first part is it has to return an IEnumerable, and we'll sort of stop right there for a moment. What each entry in the IEnumerable corresponds to is going to be the data for one single test case in the theory to run. Now the entries inside of the IEnumerable are going to be an object array. So the entries in those arrays are supposed to correspond to the particular values that you're going to be passing into the test case. So in our case, since we have a single currency parameter, that means that the object array should itself have a single currency parameter. So it helps to view this sort of as vertically. You're going to arrange your individual test cases, so each line is a test case. And then horizontally, it's going to be, here's the individual values that you're going to be using for that particular test case that you have. So what we have now is a very simple MEMBERDATA that is going to iterate through the currencies one by one. And this is effectively exactly the same as what we had with inline data, except in this case I've added currency.usd as one of the possible values. So really, you can view this as we've got the inline data, same as before. I've just put a bunch of boilerplate code around it. And the benefit from having that boilerplate code is now I get to use the single line MEMBERDATA name of all currencies. I can put that in more than one test case. Now, since we're running code to be able to generate this, you can go beyond just doing what I did here of just statically defining what the list is going to be. You can actually get a little more creative. So you can actually write a function that starts doing something a little fancier. So in this case, I've got something down here that says, hey, what we're going to do here is we're going to use this link query. So we're going to get all the values of type currency. Then I'm going to do a cast to be able to convert the objects that are in the array that we got back from get values to convert them back to the appropriate currency type. And then I'm going to put each of those individual currencies into an object array of size 1 with that currency. So this actually does exactly the same as what we had over here, but has the added benefit of when this someone comes along later on and says, time to add another currency to the currency enum, this code is going to automatically be able to pick that back up. So what's nice is we've got all these test cases now. And that's really it for the most part for xUnit. You add tests, you run tests, you fix some code, and you feel good. So let's just take the exercise a little bit further here and be able to actually look at a slightly more complicated test case. And what we're going to do is we're going to put in this new one that is going to deal with, here we go here, that's going to deal with trying to be able to do this currency conversion between different currency rates. And for this particular one, we're going to have the bank rate of 5% come out from that. So what we're going to do is we're going to take $100 in one currency, and we're going to convert it to US dollars from one of the currencies, and convert them over to the target currency that we have. So you can see that I have a member data here that says, oh, we're going to need the data that we want to have for this test case. And I've already created that. So again, I'm not going to belabor the point. I have painstakingly, before this, computed what the value of each of the individual $100 of each of the currencies are for the values that I had inside of our currency converter. Again, so going inside of here and going, oh, if we have 77.5 cents for the British pounds, that's going to correspond to, after we take off our 5%, that's going to be worth $73.62 when you convert the 100 US dollars to that. So again, I've gone through and I've converted all those and figured out what the values are supposed to be. So for the Canadian currency, we can see it's $126.44. So we can go ahead and we can run the test now, and we go through. But this time, however, we can see that we get some of our test cases failing. So what's nice about the test harness, and I said it's going to be able to run all of the test cases, well, it's going to go through and it's going to pick out the ones, or readily pick out the ones for us, that are going to tell us that we have a problem. So for instance, we can see for this one here, that we failed to be able to convert for CNY. So, and then we can see for this one, we ended up failing for, what are the currency for that one? For Canadian dollars. And if you look at all of the test cases, you're going to notice, hey, we have some rounding issues here. I was expecting $73.62. What I got back was $73.62.5. Oh, that's right. We forgot to, in the code, deal with the fact that we were supposed to be accounting for making sure that we don't end up returning pennies. So we now have a great test case that was able to find out, oh, the developer did something that they should not have done. So we can go ahead now and we can be able to put in the appropriate code to be able to give us back the appropriate values. So we can go ahead and we can put in here that what we should have done is we should have been returning decimal dot round, and the decimal value is supposed to be the amount in target currency. Put that in, and we're going to round it to 2 decimal places. So now if we go ahead and we run this version of it, so let's go ahead and now run it with that, put that in, and now we get to see that we have all the green lights. And here's the important thing. This was actually a pretty fundamental change that we had here. So that, for the most part, invalidated all of the other tests that we had that might have been potentially returning values. And this is the advantage of having the Test Explorer that we have here. This gives us the ability to be able to make potentially some pretty major changes and be able to fall back on the unit test to be able to start confirming if we've fundamentally change things in a way for the worse. Without having the unit test to back us up, then you're at the mercy of someone's going to have to do their own end-to-end testing to be able to hopefully confirm that it does the right thing. So at this point, I think we've exhaustively covered what we want to do for at least describing the mechanics of doing the xUnit tests. And what we're going to go on to next is we're going to take a look at being able to do something where we're actually going to start developing the code where we're actually using this with the Test Explorer firmly in hand. So what we're going to do is we're going to look at test-driven development.